Hey everybody, this is going to be our first Unit 8 video, and we are getting into rational expressions and functions and equations. So these are really like fractions, like big complex fractions. I want you to think of it as the division of two polynomials, which we looked at earlier in the year, and doing some basic operations. So we say simplifying a rational expression is really trying to find some common factors between those two polynomials, right? The numerator, the denominator. So we're going to start by factoring everything that we can possibly factor. And then if we find a common binomial between the numerator and denominator, we'll be able to cancel them out. If there are monomials, like if we factor out some GCFs and there are monomials in front of some of our binomials, we can use our exponent rules to simplify those. So let's look at an example. Okay, so rational expression, right? I've got a polynomial in the numerator and in the denominator. So to simplify, we are going to factor. In the numerator, I can factor out GCF of 3a, which is going to leave me with a 4a squared minus 1. Okay, I will be able to factor that binomial by difference of squares, but let me factor out a GCA squared out of my denominator first here, which is going to leave us with a 2a plus 1. Okay, so let's go back. Let's factor the 4a squared minus 1 in our numerator. Okay, again, that's difference of squares, so it'll factor into 2a plus 1 times 2a minus 1. And then in the denominator, there was nothing else that we could factor, so I'm just copying that down. Now notice, we have some monomials at the very front here. We have a 3a and a 6a squared in the denominator. So we can simplify those, right? 3 over 6 is really just 1/2. And if I have a over a squared, that would be just leaving a single a in the denominator, a to the first power. So really, there's like a 1 in my numerator. You don't have to write it, but we can. And we're going to be left with a 2a in our denominator. So the other thing that you might have noticed was we have a factor of 2a plus 1, top and bottom. So we can cancel those out because anything divided by itself is really just 1. So that's going to leave us with a factor of 2a minus 1 in the numerator and 2a in the denominator. So that would be the simplified expression. Okay, so really we could just write it as 2a minus 1 over 2a. And that would be our final simplified form. We can also multiply. So let's look at a case where it's just monomials, and then we'll move into one where we have to actually factor. Now, right off the bat, we could multiply everything and then just use our exponent rules to simplify after. So if I multiply the numerators together, I'm going to get 60, x to the 5th, y to the 7th, and in the denominator, I get 36, x squared, y to the 4th. So then I can simplify, okay? Between 60 and 36, we can factor out a 6, right? We could divide each of those by 6. That would leave us with 10 over 6. And then we could actually, a 12, that would be the bigger number that we could factor out. We can divide each of those by 12, which is going to reduce this fraction to 5/3. And then we can use our exponent rules for the variables. So for the x's, I'm going to subtract the exponents. I'll be left with x cubed in the numerator, and I will be left with a y cubed in the numerator as well. So that would be our final simplified expression. Okay? But most of the time, we're going to be looking at things like this, where we have some polynomials, we have to actually do some factoring, and this is where it can get a little more complicated, okay? We don't want to multiply the numerators and denominators together like we did with the monomials, because that's going to make a bigger polynomial for us to factor. So we want to start by factoring each numerator and denominator as they begin, okay? So we've got, let's see, for the first rational expression, I can factor out a 4x, which will leave me with x minus 1. In the denominator of that same expression, I could factor out a GCF of 2, which is going to make it a lot easier to factor this trinomial. Okay, and that's being multiplied by this other trinomial here. So remember, we need to find two numbers that multiply to -6, add to 1. So that would be x minus 2 times x plus 3. And then in the denominator, we have that GCF of 4x that can be factored out, which is going to leave us with an x plus 2. Okay, so right now, I see that I have a 4x here and here that I can cancel out. So, go ahead, do some simplifying if you can. Nothing else cancels yet, but we have to go back and we have to revisit this polynomial here, this trinomial that's left in the denominator. Let's factor that and then see what we're left with. So right now we have x minus 1 in the numerator. And then if I factor that trinomial there, I am going to get an x plus 3 times x minus 1. And you probably notice that we have some other common binomials that will factor now. Because I have an x plus 3 in the numerator and denominator. I have an x minus 1 in the numerator and denominator. So we're canceling out all those common factors, and we're going to be left with x minus 2 over 2 times x plus 2. Now, if you see division, it's just going to be the same as multiplication. Remember, dividing by a fraction is the same as multiplying by its reciprocal. So anytime you see division, I want you to just automatically change it to multiplication. Okay? Instead of dividing by this, we're going to multiply by its reciprocal. And then we can go through the problem the exact same way. We're going to factor out all of the stuff that we can, and then see what cancels out. Where are our common binomials? Okay, in the numerator here, we're going to be able to factor this into an x plus 3 times an x minus 2. We've got quite a few common factors here. We have some x plus 3's that cancel out, x minus 2's that cancel out. So let's rewrite what we've got here. In our numerator, we've got 10. In our denominator, we have an 8x. So if we reduce 10 over 8, we can get 5/4. So we really have 5 over 4x. All right, that is it for this first video over rational expressions. It is a lot of factoring. We've done a lot of factoring this year. It's been a little while, but hopefully it's coming back to you. We're going to be utilizing factoring a lot for rational expressions. Have a great rest of your day.